All right, my friends, let's take a look. So for this one, you do see one function of x being multiplied by another one. Um, but before you do anything crazy like integration by parts, which I do not think, I think you would immediately hate it if you considered integration by parts for this one. Instead, I want you to notice that this problem, we have compositions of two functions. So, cosine cubed x is cosine of x is the inside function, and then the outside function is x cubed. And then the same thing for sine to the fourth x. That means your inside function is sine of x, and your outside function is x to the fourth. And whenever you see a composition of two functions like that, I do want you to consider u substitution. And so for this problem, I want to show you what it looks like to kind of play with the idea of what if we let u equal cosine of x versus what if we let u equal sine of x, since those are both inside functions for this one. And I kind of want to show you what it looks like when this goes well and when it doesn't. Okay. All right. So first, I think I'm going to show you the one that's actually going to go well. And it's going to be the second option here. So this is going to be the winner. So let me show you why this works out so well, and then we'll also talk about why the first one wouldn't. Okay. So if u is equal to sine of x, then your du would equal cosine of x dx. And so what you're going to want to do with a situation like this is before you do your u substitution, you're going to rewrite your integral. And let me show you how you're going to do it. So whatever you let u equal, you'll write that one first. So you let u equal sine. So write sine to the fourth x first. And then the cosine cubed that you have left, you're going to split it up as cosine squared x times cosine x. And why did you do that? Because you wanted to make sure that you had your du there. And then sine to the fourth x, that's easy to write in terms of u, that's u to the fourth. And then the reason that this version of the u substitution is working so well is because this cosine squared x, which is super inconvenient, can be swapped out using a Pythagorean swap. It can be swapped out with 1 minus sine squared x, which would equal 1 minus u squared. And so this is what it looks like if your u substitution is working. When you've got like an integrand with products of sine and cosine to various powers. This is what it looks like when it's working. And what made it work, really what made it work was that when I reserved that cosine x dx off to the side, I was left with kind of the unwanted trig function to an even power, which means I can Pythagorean swap it into the other trig function, the wanted trig function. So anyway, so now that I've got this in terms of u, I'm just going to copy it. I'd have u to the fourth times 1 minus u squared du. And then from there, let's just turn this into a basic integral by multiplying that in. And now we can just power rule it. Don't forget plus c. And then back substitute. U was holding the value of sine of x, so there we go. So we'd get sine to the fifth x over 5 minus sine to the seventh x over 7 plus c. And if this doesn't make sense, you could always take the derivative and see if you get something equivalent to that integrand. There you go. Now, before we move on to the next example, I do want to talk with you about why this version right here wasn't going to work. So let's kind of show that. So if u is equal to cosine, then du would have been the opposite of sine. So if I'd taken this integral and kind of, moved things around, let's see, I would have had cosine to the fourth x, or sorry, cosine cubed, that is. And then the sine to the fourth, I would have had to split up as sine cubed x times sine x dx. And the reason I do that is because I'm trying to have somewhere to put, well, I guess not du, but negative du. And then that would have been u cubed. And then this is making me sad because it's cubed, it's to an odd power, and I just can't Pythagorean swap my way out of that unwanted trig function. It's not going to be any fun to get that in terms of cosine, essentially. So hopefully that's making sense. Okay, so we're just gonna say nope, that's not working. So that's part of what will make chapter 7 a little more challenging, is that when you see an integral, you're going to have more than one idea pop into your head, and you're going to have to be willing to explore a couple ideas before you land on something that will work, or maybe like the path of least resistance. So be willing to brainstorm a little bit before you fully commit. So hopefully that makes sense. Date around before you marry the math problem. There you go. I don't know. There you go. All right, my friends. Example 2, go ahead and poke this one with a stick. Integrate sine to the 4th x dx. Good luck.